You know about the crust. That's the top most layer of the earth, and that's old crust on which the vast continent and the mighty oceans lie within the crust. And that crust is basically made up of variety of rocks. It could be igneous, it could be sedimentary, it could be your metamorphic rock. Okay, and these rocks have developed their internal structure over the years. Okay, so internal structure means if I see any structure of rock looking like this, okay, or any kind of deformation actually. So originally, let's say I have a block here, or I have a sedimentary strata, or I have a rock body, sedimentary rock body. So these are the layers of the rock. Okay, and for some reason, for earth processes, what happened, this rock body is gone through a deformation. Okay, and I am considering here you are giving pressure from the both side. So compressional stress you are giving, to be exact. So in geological or engineering geological term, you will be saying that you are giving the compressional compressional force, okay, or compressional stress. Okay, so what will happen, just like anything will happen, if there is a book and you are pressing from both sides, then what will happen, it will bend, like this. Okay, or it may have another flank. This structure is called fold. So this is actually whatever I was discussing, that's the general origin of fold. So this kind of deformation generally studied in structural geology subject, and the response to the stresses and strain which are there, which this rock was subjected. So it's introducing where you are getting the stress. I told you in the previous class that the plate tectonics, the plates are moving. So consider a simple example, the plates are moving, in between there is a sediment deposition, or in between there is a sedimentary rock, or in between there is a uncompacted sediment deposition. Then what will happen, it will create a mountain like structure. So two plates are moving, and in between you have a sea which is filled up of sediments. So if it's moving this side like this way, so this sedimentary strata or sedimentary structure will be folded like this. Thus this is the one example, or this process happened in the formation of Himalaya. You might read in your school geography, but okay. So this stress or introduction of this stress or these things are very common, and in response to success and strains to which they are subjected from time to time since their formation. Despite its antiquity and the apparent stability, the crust, the topmost layer, is always in the unrest condition. Unrest condition means something is happening all the time. The dynamic nature of the earth is not leading the earth's crust into a stable condition. So sometimes you will find earthquakes, sometimes you will find another processes are happening, sometimes you will find the eroding is happening, sometimes you will be seeing the isostatic equilibrium. So these things are there. For our sake of simplicity, we will consider the earthquake. So generally how earthquakes are formed, strain accumulating over the years released suddenly, and that create a havoc energy which is propagating as an earthquake wave. Okay, that is propagating as a seismological wave. So in the process of earthquake, it basically ruptures the surroundings, it basically changes the surrounding things. So due to the earthquake, another thing might happen and generally happen, that is the fault. Okay, so there will be a fracture. So if you are vibrating something or if you are giving stress, a sudden stress to any rock structure, what will happen? It will break, and that break will be happening through a or via a plane of weakness. Let's say it's a plane of weakness is this one. For some reason plane of weaknesses are developed, and this weak plane will be acting as a fault plane later after the earthquake. So what will happen? This portion, okay, these are the strata I'm considering. So what will happen? The upper block will move down a bit. Like this one. So it will goes down or it may go up, and it's called fault. And sometimes you will see the fractures are developed, and in a pattern you can see, like rectangular pattern or any other pattern you can see, and in between them there might be some cemented material or chemical precipitation, or कुछ भी नहीं हो सकता है, okay, or there wouldn't be anything. So it's a simple weak plane. If you press or if you apply a small pressure, then it will be detached from the, so this block will be detached from this block if you pressurize this block a little bit. So it's a, these joint planes are basically a plane of weakness. These are the weak planes. Okay. Now, due to the earthquake and these things or the isostatic adjustment, Indian peninsula means the Indian continent, the India, basically it's surrounded by three sides surrounded by water and one side surrounded by continent, so it's called peninsula. And this Indian peninsula thing is this Indian peninsula, eastern and western coast, most of the cases. Recently there have been studies, and they have found out that recently these coasts have been uplifted. Means the surface of that continent goes up by 100 to 150 feet. Of the Indian peninsula. So these things are very common, the upliftment or the subsidence. There is another example of subsidence is from the Arakan coast. Where is Arakan? Does anyone know where is Arakan is? It's in the South India side. Anyone know where Arakan coast is? From Andhra Pradesh? Anyone from Andhra? Araku. That's the Araku Valley. I'm talking about the Arakan. Whatever. So in that Arakan coast or Arakan coast area, it's a Bay of Bengal and it's around the Andaman Island. It's around the Andaman Island, and this Arakan coast, this area subside up to certain amount. So this undergone subsidence. So you should understand this point, the point of stating this fact, that the surface you are saying, the existing soil cover you are saying, it might be eroded, it might be the portion could be uplifted, or that portion could be goes down. There is there are several examples of earthquake you might have seen in the news, that some portion of one place goes down or subside, and these things are very common. That was my objective. So there are always forces which are playing with the crust, playing within the crust, and within the crust means with the rocks, and they basically leaves a imprint. or they basically leaves a print on that rock by permanent deformations or by doing the permanent deformation and all. And as they do impart the constituents rock certain characteristic structures, their study, their interpretation is very important for us to understand the let's say recent tectonic activity or the past tectonic activity. Other than it has also economical importance that I will discuss when I will be discussing fold, fault and joint. Okay. So structural geology is a subject or is a branch basically consisted so is the study of factors which basically consider the origin, occurrence, classification, type and effects of various secondary structures. So what are the various secondary structures? What is the first structure? So first structure means when the rocks are forming. Why secondary structures? Means it developed after the origin of the rock. That's why I am talking about it's a secondary structures. What are the secondary structure? Folds, faults, joints and rock. This is a fold. This is the folded. I have already discussed how fold are generally developed. Fault is I have also discussed. Have you seen the fault line? This is the fault line. Okay. So if you see here that on either side of that fault line, which I have marked, what you have seen that this dark band, lighter band, dark band, dark band, lighter band, dark band, and you can easily, by seeing this figure of picture, you can easily say that either this point and this point were intact before the faulting happened, before any large earthquake happened. This was there, this point and this point were intact. See, लग नहीं रहा है, थोड़ा सा displace हो गया है. So it displaced from its original position. There is a offset. Okay. Originally this was a one whole rock and which become displaced. Two things might happen. So this might goes down, which is considered generally, or this might go up. Two things might happen on either case, and that will be discussed in the fault when I will be discussing what is a normal fault, what is a reverse fault. So here you can see that there is a displacement, and this thing is a huge hilly area. So you are getting the idea. And in case of fold, see the structures. Fold could be of 10 to 100 kilometer wide, or more than that. Okay, so this structure I am talking about is the huge structure that required huge amount of force. Similarly, this is the photograph of joint. This is a special type of joint. It's called columnar joint. That will also be discussed. So you can easily, it's kind of consisted of flaky kind of structure. You can easily separate one block with another, and it look like consisted of several pillars joined by some cemented material, or it may be joined by the weak plane. Okay, so these things will be discussed, but before discussing this or before understanding this part, in today's class we will be discussing few basic parameters of structural geology, which are strike and dip. That's the most important, two more important characteristics or two important parameter for structural geology. Outcrop. What is an outcrop? It's a geological formation exposed on the surface. It's called the outcrop. Now let's discuss about the strike and the dip. To understand strike and dip, let me draw one inclined plane. I am considering this plane is inclined. Okay. Okay. Now, for better understanding, so this is the inclined plane, and on this inclined plane what you will be doing, you will be considering a horizontal plane. So that's a horizontal virtual plane you are considering. So this is the horizontal virtual plane I am considering. So two things are there, one is strike, another one is deep. So let's first discuss the what is deep. Deep will give you the idea of the inclination of the plane, inclination of a bed with the horizontal. So this is a virtual structure, okay, this horizontal plane. So the angle it's making, it's called deep. This angle is, let's say, theta. So theta is our deep angle. Okay, this thing is clear. Now what is the strike? Strike is the line which intersecting, so this dipping plane, this is the bed rectangular way, and this portion of the bed is intersecting this virtual horizontal plane at this line. So this will be our strike. This line is our strike. Generally we denote strike as SS and depth as D. Okay, so let's say the angle is making with the horizontal surface, horizontal plane. So this is our horizontal plane. So the angle is making with the horizontal plane, theta equals to 30 degree. Okay, one thing I didn't mention intentionally for the deep part, I'll discuss it after completing this portion. So first understand how do you estimate strike, or how do you calculate strike and deep of a bed. So this is the bed and this is how the bed is oriented. Okay, now I'm taking the strike direction. I'm only taking the strike direction. So I'm putting this line here. So this is the line, this is our line SS. Okay, this line, and on a horizontal plane I can, what I can do, I can always consider the directions. So we have four directions: north, south, east, west. This is north, this is east, this is south, this is west, and the angle here is making, let's say it's 20 degree. So what would be the strike of this plane? This one of this plane, what would be the strike? So there is a several way to write the, or several style to write the strike. So first style you can adopt, that you can write the angle is making with the north in which direction? In east direction. So the angle is making in 20 east, and always follow the right hand rule. क्योंकि तुम लोग पूछ सकते हो कि सर हम तो इस एंगल को भी ऐसे करके दिखा सकते हैं और ले सकते हैं, यहाँ से भी एक एंगल बन रहा है, मैं उसको भी ले सकता हूँ, but always consider the right hand rule like this. Okay, these are not taken. So by following the right hand rule, it's making 20 degree angle with the north. So I'll be writing the strike is in 20 degree east. Okay, and now let's consider another way of writing. So this is our style 1, style 1. Style 2, you can write in a way like like this is the 20 degree, so you will be writing 20 degree, and what angle this would be from the north, what angle this should be? from here to here? Class? Are you listening or not? Vijay, what angle this should be? From here to here? What is this angle? तुम लोग सुन रहे हो कि नहीं?
यस सर.
यस सर मत बोलो, बोलो ये एंगल क्या होगा? एनीवन?
सर 200
200. तो यही तो पूछ रहा था मैं, सुनते ही नहीं हो, फालतू का बक रहा हूँ. ओके, सो you can write this in this way also, 20 degree hyphen 200 degree. Another way you can write, okay, another way we can write that you will be considering the clockwise condition, and suppose it's a 20 degree, so you can also write the strike is only 20 degree. Okay, here you can put north here. You may put, sometimes you will find that people are not using the n, so it's a common conception that we are taking or measuring the angle from the north, so that will be okay. Now if you set the angle is 20 degree or 200 degree, that is also fine with the writing. Now we have to find out the dip. Be attentive class, I will be asking. So in case of deep condition, first I have to draw, I am taking a line here, okay, which is representing this surface. I am taking another line which is representing this surface. The angle is theta. Okay, now how would you define the, what would be the deep direction? What would be your deep direction? So the deep direction can be estimated from this plane, like, so this is the strike direction, which will be perpendicular to the deep. The deep direction will be always perpendicular to the strike direction. So whenever you will be taking this line, you will be choosing the line perpendicular to the strike. So this angle is your 90 degree. This angle, this purple colored angle, the angle between strike and deep is 90 degree. And then you are taking a line on the horizontal plane. The vertical angle it's making, it's called the deep angle. Is it clear to everyone? So deep direction would be the direction of this side, simply from this method, this direction of the deep. So what direction is this? So deep direction or deep will be written 30 degree, and the direction is, what is the direction of, what is the dipping direction? Tell me from the map. From this map, tell me what is the dipping direction. ये डायरेक्शन क्या है? ये इसको क्या बोलते हैं? साउथ ईस्ट डायरेक्शन ना. सो 30 डिग्री साउथ ईस्ट. 30 degree is the deep amount. Southeast is the direction of the deep. So if I want to write that, if I want to characterize this bed, or if I want to write the bed orientation, okay, if I want to write the bed orientation, or if I want to make you understand how the beds are oriented, then I'll be first writing in 20 degree east. पहले इसको समझो, मैं एक्सरसाइज दूंगा अभी, ठीक है ना. इन 20 डिग्री ईस्ट, एंड deep will be, the deep you will be writing 30 degree southeast. This is how you will define a bedding plane. So this is very basic for a structural geology. Now you have the idea of strike and dip. Now what will happen, tell me. You people are from civil engineering branch, so these things are very easy for you, I think. Now tell me, if you take this line not perpendicular to the strike line, if this line is not perpendicular to the strike line, then what will happen? So I am taking an oblique line and I am taking another line, let's say from here. So what will be the angle here? Let's say the angle is phi. What will be the relation between theta and phi? Will theta be greater than phi or will theta be less than phi? phi से ज़्यादा होगा कि phi से कम होगा थीटा का वैल्यू? Which one will be the smaller angle? Class, which one will be the smaller angle?
So theta will be smaller.
Are you sure? Are you sure? Now don't tell me that phi will be smaller. Okay. So this is the inclined plane and this yellow book is your horizontal virtual plane. Okay. So the angle it's making is will be maximum when we are talking about the vertical one. If I take the oblique angle, then the angle will be smaller. See here, is it visible or not? ऐसा क्लास नहीं होता है. So do you want a surprise quiz or not? मैं इसके ऊपर मार्क्स दे दूं तुम लोगों को चुप रहने से? Section B is more interactive than you guys. So phi is always will be less than theta, and theta is called the true dip condition. When we are taking this line, when we are taking the inclined line perpendicular to the strike direction, then your dip value will be the actual dip value, that's called the true dip value. If you take any oblique line, it will give you a apparent dip value. So dip could be two types, true dip and apparent dip. So true dip is the angle between the plane and the horizontal plane is normal to the strike. That's the important criteria here. It should be normal to the strike. Apparent dip you can take in any angle. Okay, so to understand true dip and apparent dip, suppose this is the inclined plane, inclined bed or inclined plane, and here you have take AB perpendicular to the strike direction. Strike direction is here. Okay, now this is the this top layer of this cube or this structure is your horizontal plane. So this angle will be your true dip condition, and this angle, the angle TPS, you can see it, right? TPS will be smaller than the angle BAC. So BAC is the true angle and this one is the apparent angle, like this. This is another example. So if you take perpendicular line, then it will give you good result. If you slanted it, then your angle will be smaller. You can see this from this 3D figure. Now strike and dip directions, what should be, why I am talking about true dip and apparent dip. So true dip condition is true dip condition is the actual dip of the bed. Sometimes see, if you are doing some trenching work, like if you want to place a railway track, then there you generally do a trenching, and it's not necessary you are cutting in the vertical face. Vertical face means it's perpendicular to the strike line. So PQ face is the vertical face, you are not cutting. So you will be seeing A side is the horizontal one, and this bedding, the actual inclination of the beds is this one. This one and this one is giving you the apparent value, A and B. A and B side is not giving you the actual value, like this one. So if you cut this vertically, then you will have the actual dip, and if you cut this in any other angle than the vertical direction, then you will have this kind of angle. So you will have the apparent dip angle. So true dip angle is always greater than the apparent dip, and apparent dip angles generally are smaller than the true dip angle. There is another term called azimuth. So it's a horizontal angle measured clockwise from the true north, which has an azimuth. So azimuth means if I want to find the azimuth here, okay, azimuth of sun, let's say. So from your observer point, you are staying or you are standing there. This is the line, or this is the straight line between you and sun. So you will be projecting the sun on the ground, or any star, let's say. So there is a star, or there is a hot air balloon in the air. So you will be projecting that into the ground, okay. And if you are projecting this point into the ground, and there you will have a straight line from observer point to this point, and that line, if it's making angle 30 degree with the north, then it will be said as its azimuth at 0.030. As for example, east side has an azimuth of 090, while the southwestern side has an azimuth of 235. Got it? So that's called the azimuth. Now another thing is there is called plunge. Plunge is kind of it's the general sense of measurement, and it's the angle between a line and the horizontal datum plane. So plunge basically measures the angle of linear features. The plunge is measured in the trending direction in a vertical plane with respect to the horizontal datum. Now what would be the trend? Trend means it's a very common one for geological measurement. सिविल में भी तुम लोग शायद यूज करते हो. सो ए, सो सपोज ए इज द पॉइंट ऑफ द ऑब्जर्वर एंड बी पॉइंट को तुम देख रहे हो. यू आर सीइंग दिस पॉइंट बी थ्रू क्लाइनोमीटर कंपास और एनी अदर काइंड ऑफ कंपास. Then the angle is making with the north, that will be your trending angle. So suppose this is the north direction, the angle is making, let's say the angle is making 45 degree, so the trending direction will be 45 degree. It's called the trend. From one point with respect to one point, what is the position of the other point, that gives you the idea of trend. And plunge give you the idea of the inclination of a bedding plane or any linear features. What is the inclination of that linear features? So suppose there is a linear features here, like joint or any other structure, and you are seeing from here. So what is the inclination from the horizontal surface or horizontal horizontal virtual plane, that will give you the idea of plunge. Okay. Okay. In your next class, I will be discussing on folds. One more thing I will be doing, that